My name is Dhawal Chawda, and today we are going to learn about satellite communication and Earth station. So these are the contents that I am going to cover. That is fundamental of satellite communication, geostationary orbit, Earth station and look angle, satellite transponder, link budget, etc. So the first slide tells about what are the fundamentals. So the fundamentals are these three laws. Kepler's law. The first law suggests planets orbit in ellipses with Sun at one focus. Satellites follow elliptical path around Earth with seat at one of the focal point. The second law states planets sweep out equal area in equal times. That is, satellites sweep out equal area equal in time intervals, meaning its velocity is highest at closest point and lowest at farthest point. The people who are educated have termed perigee and apogee. Third law states the square of the orbital period is proportional to the cube of its mean distance from the Earth. These are the Kepler's law which is very useful for us. So the main thing which is satellite communication, and that is it's essentially a spacecraft carrying communication equipment that creates a link between distant point on Earth. And to apply this, we need to refer these laws. So these are the Kepler's law from which the foundation of satellite communication is built. What is geostationary orbit? It's a specific circular path about 35,000 km about Earth's equator. Here you can see this is the geostationary orbit where our satellite revolves. The distance is 35,000 km from the Earth. Where a satellite orbits at the exact same speed and direction as Earth rotates. So it will appear as it is a stationary from the sky, and it is ideal for constant communication and weather monitoring. Why it's used? As we discussed here, satellites stay fixed over a region which allows constant communication, and the applications are TV, radio, and data. Offers wide coverage with three satellites providing near global coverage. This was about I'm sorry, this was all about geostationary orbit. Now we will talk about Earth station and look angle. Earth station. These are fixed or mobile antennas on Earth designed to communicate with these satellites. There are mainly three Earth stations, one in America, one in Spain, and one in Australia. These are the three main Earth stations where we communicate with deep space satellites. So they require precise pointing to focus energy towards narrow beam of satellite. Look angle. To establish a link, Earth station's antenna must point directly at the satellite. So this alignment requires two angles. As you can see it requires two angles. Elevation angle and azimuth angle. Azimuth is horizontal angle measured from the true north, and elevation is, here you can see, the vertical angle measured upward from the local horizontal plane. Why they are important? For the precise aiming. For fixed that is geostationary orbit. That is why we need Earth stations and look angle. Next is satellite transponders and link budget. What are transponders? They act as relay station in space, receiving signal from an uplink station, boosting their power, changing frequency so that interference can be avoided. sending them back to the downlink station. Here you can see what is uplink and what is downlink. Here there is a Earth station, point A. It's sending data to the satellite. Here it is the relay station in space. It receives signals from a uplink station. Now it will boost the power, it will change frequency, and it will send back to a downlink station which is located at point B. This act is called transponder. It includes low noise amplifier, frequency converter, and high power amplifier. Because the distance is too long, we need high power amplifier to send it. Again, the distance is too long, we need low noise amplifier to receive it, to receive signals. Because of the distance, we are sending data at very high distance, very large distance. We need something so that it can reach to the relay satellite. So because of that, we need high power amplifier. But to receive it, there is also long distance to receive, and the Earth station A and B are very far. So there must be a very powerful receiver to receive the weak signal so that we can receive the data. And for that, we use low noise amplifier. What is link budget? A comprehensive power calculation for the entire communication path, that is uplink plus downlink, to predict performance. Determines carrier to noise density, required energy per bit to noise density, data rate, and bit error rate. Next is attitude control, station keeping. To keep the satellite within the designated orbital box or the location, like solar radiation pressure, Earth's gravity anomalies. There are two types: Earth east-west and north-south. East-west corrects longitudinal drift, and north-south corrects inclination changes. What is attitude control? Attitude control is to control the satellite's pointing direction so that antennas point to Earth, solar panel face the sun, and instrument look at target. Here you can see it is the whole attitude control system, the block diagram. From sensor it goes to comparator, from there it goes to processor, to correction system, the TT&C interference, it goes back to satellite attitude, continues the cycle. So this was all about satellite communication. Thank you.